Alright, in this video I'll be going through each of the Ox Rock Tools HDAs for the Rock Tool Suite. And this is an example file that'll be included with the package. Okay, so first we start off with the Ox Rock shape node. This gives us our base rock shape, and you can see here that we get kind of by default got a nice generic rock shape with it. This node either will use a default sphere. If we take down all the modifications of the faces, we see that it is a sphere, and let's take down the bottom as well. So the node either takes in this default sphere, or we can give it a geometry, and the geometry does need to be convex because of the way the rock shape works and the way it deforms, and the faces all need to be convex. And I'll explain more of that as we go along. All right, so this one we're taking in this geometry and then modifying it, angles and everything. All right, so that's the two sources. Get rid of that. Rock seed. We have our flatten height. This will flatten height and flatten strength. Give us a nice flat rock bottom. And if we want to clean up the geometry under here, we can use the bottom clip pipe, and that'll fix that edge right there. All right. We have convex hold. This is just a quick little toggle here. I leave this off by default because the way that some of the Rock Tools HDAs work is they work on the faces per primitive, and so even though these are invalid polygons, they still work a certain way with the tool suite. If you're having trouble, or if you want to see a different result, you can go ahead and check that on. You could also just use the convex hole node separate. Set on ground is handy, and set largest face as rock bottom is really nice. So if we don't have that checked, it's just the default geometry without any orientation. But once we check this one, it'll measure the largest face on the geometry and set that on the ground as the bottom, facing downward. Okay, now we have our mod planes, and so let's switch that one off. We have the random offset by normal, so the offset is perpendicular to each primitive, and this is the percentage, so it's just a random selection of the faces, and we have a seed with that as well, and this is the maximum offset it's allowed to have. We have a seed for that as well. Now if we turn that off and turn on random orientation, this is, and let me switch this set largest off so it stops moving around for a second. So this randomly orients the faces, and this effect can give us a really angular and asymmetrical geometries. So this is just for me the most fun way of exploring rock shapes. And has some more use cases I'll show you in just a second with the next node, which is the rock shape loop. Okay, so there's all that. We can extract a slab. So we have the thickness of the slab and the center point that's along the vertical axis of the slab, of the rock, I mean. We have a taper. We can taper in, taper out. We can do X and Y. So there's that. Just mind you, when you're using the taper, that you can potentially create some concave angles, and so you'll need to rework that if you want to do more stuff with some of the rock shape tools. We have freeze prims. What this does is I have this geometry set here, and I have a spread angle, and we're creating a group here. And then when we go to modify it, any of the primitives that were set in the freeze group will not move. They won't be modified. Their angle and offset will be the same. And the other primitives, only the other primitives will be modified. So that freeze group is specified here. And we're using the visualize output to see which primitives were frozen. Next, we have the mod weight. And here I'm just setting mod weight based on the Y position value of the primitive. And so when it goes to implement that, the mod weight near the bottom isn't going to be as pronounced as at the top, so that these values will be multiplied. That mod weight from 0 to 1. So it'll have a greater effect on the primitives near the top. So that's another way to control the shape of the rock. What else we got here? Okay. Yeah, and that's it for this node. All right, now we're going to take a look at the Ox Rock Shape Loop node. So this node is essentially the same as the Ox Rock Shape node, except that it has a few extra parameters up here that let us iterate over multiple iterations of the node and combine the results of those. So let's go ahead and see what we have here. We have 4 iterations, and let's change some of this offset. So as I change some of this offset, we see that we have some new variation in the edges. And so what this is doing is it's maintaining the core rock shape, but giving a little bit of variance to those edges to break it up a bit. And you could take this, a lot further, and this can create some really neat like ledges and lips for the rock. Let's bring it down a bit, and then we have different seeds. How this looks, how many iterations. You can go crazy with it. We can modify the angle a bit. So you can get some pretty neat, add some complexity to the rock, and still maintain a similar look to the base rock shape. One thing to note here is when using this Boolean each result, and you will want to use this for many reasons. So let's go ahead and take a look at what's happening here. Let's drop down a clip node and take a look inside. All right, so if we don't have the Boolean each result, we have multiple rocks in here, and we don't want that going forward for most cases. So we could Boolean each result. Now, in Houdini, when you're going to use a Boolean on multiple geometries, if there are shared faces, I notice that the Boolean node suffers a lot. If there's a plane and another plane intersects that plane, and a Boolean operation runs on them, it'll really bog down Houdini and create some glitchy results. So what I have implemented in here is a protective offset. It's just a very tiny, minuscule offset so that the planes don't intersect with each other. and the Boolean runs a lot faster. I don't know why that's how it works. It just works that way. I wish it didn't, but you can modify that a little bit here if you need to for any reason. But for most cases, just kind of leave this on and you can ignore it. What other options do we have? Random seed by offset. This adds even more random seed per iteration for the different parameters for these seeds here. I'm going to go ahead and turn that off though. All right, and then the rest of it works the same. So the freeze prims, the mod weight, all that will still be considered for each of these. All right, now I'm going to go over the rock surface node. So this node is pretty much a glorified mountain node. It's just that when we're working with rocks, it's a real pain to work on the smaller scale that a rock is found on compared to terrain that the mountain node was originally made for. And so I have some really handy things I'll show you in a minute for working with rocks with this. And let's just go ahead and go through it. So I have a basic rock shape set up here. And then I have kind of a low resolution rock surface here. I'm just giving it a little bit of a shape to it. And one of the features of this node is the geometry that comes in, we can remesh it and higher or lower the resolution depending on what we're doing. And this also comes with a kind of a blurring of the normals, point normal setup in here. When you are using the mountain node to displace the surface, oftentimes the geometry is going to have some nasty intersections, and so this blurring of the normals can really help it so that it doesn't intersect, doesn't create those bad intersections and bad geometry. So that's just handy and already set up for you here. We have a little normal cusp angle, pre-surface smoothing. We can kind of smooth it before we work with it, which is another way to help mitigate some bad geometry intersections. Set it on the ground. The mountain sop is pretty much everything you would find in the mountain sop. I'll go ahead and click on this one. This is kind of the next node. We're building up our noise, and I have more detail with my pre-remesh going on in here. So first of all, we have an amplitude divisor factor. You can see that I'm moving this and it isn't an overwhelmingly large value like it is with the mountain node. You can see I can change this divisor factor, and that'll change that. I can set it to the highest setting and it'll, just kind of nudge that, just add a little value if you need it. Just something nice and handy. And then you have your typical, the different noises and what types of offsets you want, element size, fractal warping, all that kind of stuff. In addition to that, we can quickly add a secondary mountain layer. So it uses all the same settings as above, and it just changes a few of the settings. So the amplitude, element size, offset. So this, just to get some quick complex noise adding up on top of what we're working on. I have a nice little bottom mask feature. So we have our bottom, and so I can, let me see down here as well. It's kind of, All right, so what this does is it makes it so that the noise doesn't affect the bottom. And that's nice if you have like, if you want the bottom of the rock to kind of stay pretty much the same. So there's that there. And then at the very end, we have some cleanup that we can do. And so if there are intersecting geometry, we can clean that up, and it should straighten it out. And I don't have anything to show you here on that, but just trust me, if you have intersecting geometry, you'll want to click that and play with these settings until it's clean. And sometimes you will also need to do like a polyfill after that. I have a cleanup in here. This is just, all this cleanup stuff is just kind of there for convenience. I do have some use cases where it's just really nice to be able to clean up the intersections, smooth those out, and then use a little polyfill. But these are just here for convenience. Usually you'll want to have those on their own. But you can go into the node and see how those are set up and see what's going on for like the intersection smoothing. All right, so you just add in the noises. I like to use a lot of the sharpen node, gives it a good shape and feeling. And then pile on some more noise. Do a final sharpen with a little bit of smoothing on the edges. And there you have it. Kind of a nice rock surface built up with a few of these rock surface nodes. And yeah, there you go. All right, now I'm going to go over this Ox Rock Sharpen node. So this is pretty much just the lab's Sharpen node with some handy, a handy wrapper around it that just makes it a little easier and quicker to work with. We have the apply sharpen up here and a post remesh. And I've noticed that after you use the sharpen node, you're most likely going to want to remesh because it really gives you not a bad topology, but just a warped topology. Really gets pinched, like the size of the polygons. So we have this post remesh here. You have the remesh strategy. The remesh shop is kind of just the best. The quad remesh can do some really high amount of polygons pretty quick, but usually has some issues. So you probably want to break out and do that. Use it by itself for now. It is in beta, so it tends to have some errors in the geometry. Fast remesh can be nice if you have some UV set up. Remesh size here. This is all just the sharpen node, just straight from the lab sharpen node. So you just play around to get what you like. And you can get just some really nice effects from using the sharpen. So play around with the different settings, the different kinds of different strategies of the sharpen, and there's different options depending on what you choose. And then I have this kind of a post blur, which is nice. So we have our edges, which can get a little bit too sharp in some cases. If you don't want them, you want to take a little bit of that sharpness off, you can blur the edges as much as you like. So those are the convex edges. You could also do the concave edges. So let's see where we have that going on. So like right here, we have some concave edges in here. And if I apply this blur, it'll just apply to those concave edges. Here's without the sharpen. Here's with the sharpen. So just a handy tool. All right, now we're going to go over the rock layers node. So I just have a basic rock set up here, a little bit of a rock shape loop, giving us some variety. And now the rock layers node. All right, so I have it cut into 8 pieces, but we can specify more here. Oops, I did 83 pieces, that's fine. We can do terraced slices. This will just take that intersection and then extrude it out so that we're no longer using the surface, but a terrace. The way the points are distributed vertically for the layers has a couple different strategies. One is to evenly divide this rock into the layers. And then when that is done, you can redistribute the layers here with this ramp. And the other way to do it is randomly divided. So what this does is this uses the scatter under the hood, and then the remap is specifying the scatter mask. So you can have quite different results this one because it is random based. So even though we're specifying a ramp here, it's only going to loosely follow it because it's based on a chance of it lining up like this. So use whichever one you want. You can get different results. I'm gonna go ahead and set that back to the default here. All right, we can boolean the results, combine them all together to one geometry. We can set each layer on the ground. That gives us kind of a slab look to it. We can give a random rotation per layer, a random XY jitter position per layer. We can do a random scale. This gives a really interesting effect for the rock. There's a random seed for that. And this last one is slate scale noise in the X and Y direction. And when we put this up, well, first let me fix this. Not terraced, okay. So we have our layers. We add a few more. And if we increase the amplitude on this, you can see we get this kind of noise with the layer scale in the XY direction. And we can affect the amplitude, element size, and the roughness. So depending on what you want, you can set that there. And just to give you a little feeling of the different effects you can get, we can get kind of a slatey rock from all this. Run it through a few more nodes I'll go over in a minute. You can get like some chunky slab rocks, or you can leave the layers off the ground and you can get like a good layered rock effect as seen here. That's pretty much it for the rock layers node. Just a handy way to kind of add some layering to the rocks and some variation. All right, so now I'm going to go over this rock bottom HDA node. So first thing we can do here is we can set a new bottom of the rock. And by default, it's going to use the largest primitive. You can also set it to use a prim group. And so I'll show you what that looks like over here. So we can either specify one primitive or many. And what it'll do is it'll take the average of these and use that as the new kind of bottom direction perpendicular to the average of these primitives that I have selected here. And when I select it, just make sure that you have this eye icon set so that it doesn't select anything behind what you're seeing, which will really mess it up. Press enter. And then I have it set to that new bottom group. And it set the average of what I had selected there. New orientation. Okay, so there's that. There's orienting. We also have and these are applied in order. First, it'll apply the flatten, and then the clip, and then the taper. So the flatten just gives us, I'll disable these first. So the flatten first just gives us a basic flattening. And we have the strength here. Then we have a clip, which can clean it up a bit. And it also gives us some like blending options with that clip, which is really nice. Gives it a more smooth transition. And finally, we have a taper. So we can taper that bottom of the rock to get just the effect we want. Depending on the look you're going for. And blending. And that's pretty much it. All right, now I'm going to go over the rock veins node. This one is a little bit advanced, and it uses a little bit of trickery to get the results we want. So it's based off of the RDB material fracture node. So to get the shape of the veins, you can go into the fracture node, add some detail, add chipping if you want. You'll want kind of maybe a lower resolution for this side of the workflow. You can run into some performance issues here with higher meshes. You'll definitely want a higher poly count on coming into the rock vein node here on the left. You can get a better resolution for it here. But what it's doing is it's using the cheapest calculation for distance, which is to a surface. And so we can have multiple sweep nodes coming through here so that we can get a similar effect if we were using a more expensive measuring method. It just runs a lot slower if we do it with a better way. So it's kind of a little bit hacky, but it gets the job done. You can play with these. We have the min and max scale, and this is the sweeping iterations will match those different sizes and create a mask based on the intersection or the distance from what is swept onto these cracks. And it'll take some playing with. The defaults can give some good results, but just play with it till you get the results that you want. And then at the very end, you can set this distance. You could have veins that pop out a bit, veins that go in quite a bit. Either way, blurring. That's pretty much it for this this node. But you can stack these up on each other and create some pretty intricate veins. They're just going to need high enough resolution to of the mesh to really come through and look good.